In the heart of Florida, at NASA's Kennedy Space Center, a new chapter of space exploration was about to begin. The Artemis program, named after the Greek goddess of the moon, promises to return humans to the lunar surface for the first time in over half a century. And yet, before astronauts can step foot on the moon again, a monumental test had to take place. This is the story of Artemis 1, an uncrewed test flight of NASA's new heavy-lift rocket, the Space Launch System, SLS, and the Orion spacecraft. A journey that would take us farther into space than any spacecraft designed for humans has ever traveled, and that would face nearly every challenge imaginable. Artemis 1 wasn't just another space mission. It was the culmination of decades of planning, engineering, and overcoming countless challenges. The Space Launch System had been in development for more than 10 years, as NASA sought to build a rocket capable of carrying humans to the Moon, Mars, and beyond. The SLS is powerful, flexible, and capable of lifting massive payloads into deep space. The Orion spacecraft, atop the SLS, is built to carry astronauts to the Moon and eventually to Mars. But before humans can board, the uncrewed Artemis 1 mission would serve as a critical test flight. Its goal was clear: to ensure that everything, the rocket, the spacecraft, and the systems, worked as planned for the future missions of Artemis. However, as with any major project, it wouldn't be a simple task. Even getting the rocket off the ground would face enormous hurdles. And it was the first time in nearly 50 years that NASA would attempt a launch of this scale since the Apollo program. As the countdown to launch approached, anticipation built. This mission was far more than a routine test flight. It was the first step toward humanity's return to the Moon and possibly Mars. But before Artemis 1 could take off, there were problems to solve, weather to contend with, and issues to address. The rocket's massive scale presented a new challenge. Standing over 322 feet tall, the SLS rocket is the most powerful ever built by NASA. But with power comes complexity. The rocket required exacting coordination between teams, precise fueling procedures, and perfect timing. The cryogenic fuel, liquid oxygen, and hydrogen needed to be loaded into the rocket in the right sequence, at the correct temperature, and under the right conditions. Every step was a potential risk. It wasn't long before the first of many unexpected challenges emerged. Weather delays, technical issues with the rocket's fueling system, and glitches in the software that controlled the launch sequence started to pile up. At one point, the launch was delayed several times, and each delay added another layer of tension. But Artemis 1's journey was always meant to be a test of endurance and adaptability. NASA would need to rise to meet these obstacles because the stakes were incredibly high. Throughout the journey of Artemis 1, there were plenty of hiccups along the way. One of the biggest came when engineers discovered a fuel leak in the core stage's liquid hydrogen system. Fueling a rocket this size is a delicate process, and a leak in the system, especially one involving cryogenic fuel, can be a serious safety hazard. This issue alone forced a delay of several weeks as teams scrambled to fix the leak and conduct further tests. As if that wasn't enough, there was the ongoing battle with the weather. The Florida heat, combined with thunderstorms and high winds, created conditions that delayed the mission even further. As the countdown clock ticked away, it felt like this mission would never get off the ground. And yet, despite the setbacks, NASA's engineers and mission planners kept working. Every problem was an opportunity to test the system, to refine it, and to improve the process. In many ways, Artemis 1 was as much about resilience as it was about technology. Finally, after months of delays, engineering fixes, and near misses, the day arrived. November 16, 2022. a day that would mark a turning point in space history. The moment the Space Launch System ignited, Artemis 1 began its journey. A roar echoed across the launch site as the rocket's engines fired, pushing the massive vehicle upward. The RS-25 engines powered the SLS with a force unlike any previous rocket, burning through 12 tons of fuel per minute as Artemis 1 climbed higher and higher into the sky. It was a launch for the ages. As the rocket soared into space, there was a palpable sense of triumph. The decades of work, the delays, the setbacks, and the countless hours of planning had led to this one moment. Artemis 1 was on its way to the moon. But even with a successful launch, the journey was just beginning, and the spacecraft would still need to face even more challenges. Once in space, Artemis 1's Orion spacecraft had to prove it could handle the harsh conditions of deep space. This wasn't just about testing the rocket, it was about testing the spacecraft systems, its ability to communicate over vast distances, and its resilience in the vacuum of space. Orion's trajectory took it beyond the moon, breaking a new record for the farthest distance any spacecraft designed for humans has ever traveled. It went nearly 280,000 miles from Earth, farther than Apollo's farthest mission. This uncrewed test flight had successfully demonstrated that the systems on board Orion were capable of surviving the extremes of space. But as Artemis 1 traveled through the vacuum of space, it faced the radiation of deep space and the heat from the moon's gravitational pull. Engineers back on Earth monitored the spacecraft's systems closely. Could they handle the challenges of long-duration spaceflight? Could they handle the heat of re-entry? Artemis 1 would answer all these questions, and more. After a journey that took it around the moon and back, Artemis 1 began its re-entry into Earth's atmosphere, a high-speed descent that could reach speeds of over 25,000 miles per hour. The heat shield, which had been specially designed to protect Orion from the scorching temperatures of re-entry, would face its greatest test yet. As Orion's heat shield absorbed the heat of re-entry, the spacecraft deployed its parachutes and slowed down, readying itself for a splashdown in the Pacific Ocean. The capsule descended toward the water, sending waves of anticipation rippling through the team at NASA's Mission Control. Finally, the uncrewed Orion capsule splashed down safely off the coast of California. Artemis 1 had successfully completed its journey, a monumental success in NASA's quest to return to the moon and to prepare for the missions that would send humans back there. Artemis may first have been uncrewed, but its impact was monumental. It laid the foundation for the future of space exploration and proved that NASA and humanity are ready for the next great adventure. The Artemis program will return us to the moon, and from there, humanity's journey will continue to Mars and beyond. The crazy journey of Artemis 1 was just the beginning. The stars are within our reach, and with Artemis, we are closer than ever to reaching them.